Well, hi again. Let's continue. This part will be probably the last part of this lecture. Why should uncoordinated decisions of consumers will lead to um, socially inefficient outcome in case of a public good, but a socially efficient solution in case of a private good? Well, in this case, you can go a little bit here. Actually, I'm leaving the answer in this kind of questions a little bit to you to look to the two cases and try to find a way to describe why in one case one thing is happening and in one other case other thing is happening. In this case, it could be very well possible to say that. I mean, and basic answers are usually true. Private goods are consumed individually, while public goods are consumed jointly, basically. Um, and in case of private goods, because they are consumed individually, basically, I mean, if I consume a public private good myself, I am able to pay the price myself, and I don't need to coordinate with each other to decide how much I will buy from that public good. While in case of a public good, since they are consumed jointly, we might come together and decide together how much we buy, basically. Now let's go to the next question, which is a mathematical question. Assume John, Liz, and Alex are living in the same apartment in FK. Assume they have shared heating system, so gas used at the heating system is a public good. Draw the demand curves of Alex, John, and Liz. Show which curve represents which demand curve, and in case the decision-making process of these people are the market demand, I should say that. In case the decision-making process of these people are not coordinated. So let me erase this. And QD price. We have three people, and for each of them I will write QD. Alex, John, Liz, Alex. So the price is 2 and it increased by 2. 2. So 0. Am I right? It starts with 2. So we start with 2. Come on. And was ending at 16. Yes. 440000. For this, it is 36 and it decreases by 4, I believe. 24 and it decreases by 4 again. So, of course, we don't have negative demand, this should be 0. So this, let's draw the demand curves in this case. Basically, let me write. The first one is the Jones demand. X values are Jones X values. Y values are the price level. So this is the first one. This demand. and Alex. I'm sorry. This should be price. So look also to this demand. It's okay. Okay, this is it. This is it basically. I can improve it. And also legends. So price, quantity, and demand. So at each price level, the demand of Liz is higher, which means the demand of Liz is also the demand of the market if we are talking on a public good. So basically, the demand of Liz is the market demand. You should show it one way or the other. You can write it, it's okay in this case. That's enough showing because while with description it's already understandable. Assume the central heating system is dismantled and each apartment has its own individual heating system, so gas becomes private good. Demand the market demand curve. In that case, we should vertically add the curves. Well, we are assuming that they are living in the apartment of the same size, of course, but separate three apartments. Because if they live in a 1/3 of their original apartment, then their demand for gas might decrease a little bit. But we are not adding that complexity. So this will be the market demand. As you see, it is the vertical additions because, I mean, at price 16 and 14, the demand of other two guys is 0. The market demand curve is just equal to the list demand of Liz. But after the price goes below 15 at 12, we got the demand of Alex, which we add this length to here. We vertically add the quantity demand of Alex to the quantity demand of Liz. And when we got below 6, now we also add not only add the demand of Alex to demand of Liz, we also add demand of John to demand of Liz, since we have now 3 people basically in question. So this is pretty much this question. The next question asks, has a table where you see the TU of Selim from Selim guest from Tacos, calculate MU for Selim and draw his TU and MU curves. Let's do that. TU, MU, quantity, 1, 2, 3, 4, 5, 6. TU is 20, 38. 5460. I think this like this. Let's see. All right. So mu, well, for the first one it is equal to tu, since consuming 0 units, you got 0 utility. For the others, I should subtract the, well, tu of the, well, for example, for 2, I should subtract tu of 2 from the tu of 1. The difference between the total utility of 2 units from total utility of 1 unit gives me the marginal utility of consuming the second unit. And by making the same calculation for all units, you can find marginal utility for all units. So you can have a graph of so total utility, for which these are the x values, these are the y values. Marginal utility, for which these are the x values again, and these are the y values. Okay, so this is it. This is quantity and this is utility level. I can just Q. Let's just eliminate this. We don't have. And let's also put this here. Well, one thing you can do is actually, you might, let me see whether I can do that. Stop for a while and look for it. Basically, one thing you can do is, I mean, this type of a graph is okay, and you know that, I mean, marginal utility will start from the point where total utility also starts, and total utility goes up while marginal utility goes down, which is a logical thing. But one thing you can do is also you can assign another axis to the marginal utility by basically I'm sorry. By basically clicking this second axis. So here the second axis is actually giving you the values of the marginal utility. And you can see both curves more easily, but you should look to different axes when you are looking to different variables. In this case, I should give a special name to this axis, which is marginal utility, and this axis should have a name, the total utility. Okay, this, and you can, if you do it, you can write marginal utility to the name of this. You can name this axis yourself, I believe. So we are left with very little. Well, 2 questions left. We have 2 questions left, but we are very close to the 15 minutes mark. So let's continue in the next part, which will be the last part.